So, in this question, a car is negotiating a curved road of radius r and the road is banked with an angle of theta, right. It is a banked road, right. It is not a flat road. So, the coefficient of friction between the tires of the car and the road is given. Remember, it is a coefficient of static friction. The maximum safe velocity, at what velocity if I go such that I will not get slip or slide. Okay. So, for the banked road with angle theta, I am just, this is a two-dimensional representation. I have a car is here, right. Now, I am sitting in the car, I am going to write the equation. So, remember it is the car is turning, it is in the circular, since this is a kind of, you can think of a part of this circular road with the radius r. So, what will happen? Definitely, with respect, when you sit in the car, you feel the centrifugal force. If you analyze with respect outside, there will be a centripetal force, but if you sit in the car, right, if you are sitting in the and if you try to analyze the motion, then there will be a centrifugal force. And what is the expression for centrifugal force? It is exactly same as a centripetal force, right, magnitude wise they are same. So, what is the direction of centrifugal force? Exactly opposite to the direction of, so this will be mv square by r is the centrifugal force, right. Now, what are the other forces acting? Of course, as usual, we know mg and this is the normal force. So, for safe condition, what should not happen? Should not slide here, should not slide here, right. So, the car should not experience any net force on this direction or upward direction. So, let us just set up the equation for this condition. So, what is the force acting in this direction and this direction? You can think of this is the x axis, this is the y axis. So, this will be mg sin theta and this will be mg cos theta, because this is angle theta. Now, this mv square by r, it is a centrifugal force, right. It is trying to, so this is the direction. If you resolve as a two component, one is this direction and other one is this direction, right. So, what is this angle? This is 90 minus theta. Please understand, this is theta, this is 90 minus theta. So, definitely this will be mv square by r sin 90 minus theta. And what is this direction? This force mv square by r cos 90 minus theta. Okay. And definitely there will be friction force, right. This is very important. So, here this force is trying to take the car this direction, there will be a friction force acting in this direction. So, note that mg sin theta also this direction, f is also this direction. Why? Because there will be a centrifugal force component in this direction. So, always try to oppose this force. So, definitely it must be in the direction of the downward direction. So, now let us balance the force in this direction. So, what we have? mg sin theta plus f is equal to mv square by r. What will we know? Sin 90 minus theta is nothing but cos theta, right. Maybe I will write again so that we can understand. So, mv square by r sin 90 minus theta, and this is nothing but what? By using the sin a minus b form. Then you write the equation, remember they has to balance, right. So, this mg sin theta plus f has to exactly balance the mv square by r. Suppose if the mv square by r is greater than this, what will happen? The car will start to move upward along the inclined plane. So, but I have to balance safe turn, they have to be balanced. Then along the y direction, so what is the forces here? N is equal to, remember this is the direction of N and we have mg, right. So, the net force will be here 0. So, I can write N minus, this is a positive, so this is a negative, N minus mg cos theta, and this is equal to what? mv square by r cos 90 minus theta, this is nothing but, so this is nothing but what? Sin theta. So, now we have equation mg plus sin theta plus f is equal to mv square by r cos theta, n minus mg cos theta plus mv square by r sin theta. So, this equation can be rewritten mg sin theta. What is the force, friction force exactly at the balanced condition, right? It will be mu s n, right? This f nothing but mu s n. So, I can write, so mu s n is equal to mv square by r cos theta. But we know here n in terms of this equation. So, n is equal to mg cos theta plus mv square by r sin theta. So, substitute in the place of n, substitute this value. So, we have mg sin theta plus mu s into this fellow, right. So, mu s into mg cos theta plus mv square by r sin theta is equal to mv square by r cos theta. So, this is what we get. So, further just we have to take this two term here and there. So, we will get the final answer. So, we want only the safe velocity. You take the mv square, that's at the other right hand side, mg sin theta plus mu s mg cos theta, and we have mu s into mv square. So, if you take that side, I will have mv square by r cos theta minus mu s sin theta. Here I took a other side. So, now here all the cases m is common, I can remove the m. So, I have a g sin theta mu s cos theta, here v square by r cos theta minus mu s sin theta. So, I want only the v. So, v is equal to square, because square, so I can take this rg r sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. So, you take cos theta common from both sides. So, we will have a, when you take cos theta common, what will happen? So, sin theta by cos theta, and there will be a outside cos theta, so that will cancel. We have rg tan theta plus mu s divided by 1 minus mu s tan theta. Okay. So, remember this is a condition for safe journey, right. If this v is greater than this value, then you start to slide. So, that is a very, so this is the condition.